Assalamu alaikum students. Let's continue chapter number 10. I have given you the first lecture. Today I will give you the second lecture on this chapter. Let's start. Simple harmonic motion. First of all, we will see the definition. Simple harmonic motion occurs when the net force acting on a body is directly proportional to the displacement of the body from the mean position and is always directed towards the mean position. This is the definition which we have seen in the first lecture also. Let's see the characteristics. A body executes simple harmonic motion always vibrates about a fixed position. Number 2, its acceleration is always directed towards mean position. Number 3, the magnitude of acceleration is always directly proportional to its displacement from the mean position, and acceleration would be 0 at mean position and maximum at extreme position. Its velocity is maximum at the mean position and 0 at the extreme position. So these are the four main characteristics of simple harmonic motion. Let's see the motion of a simple pendulum. First of all, we will see what a simple pendulum is. A simple pendulum is a small heavy bob suspended by a string which is fixed with a frictionless support. A pendulum vibrates about its mean position O. When it is at point O, the net force upon it will be 0 and the bob is stationary. When a net force acts upon its bob, it starts vibrating and executes simple harmonic motion. Okay, in order to prove whether it is having simple harmonic motion or not, let's see a situation. Let's suppose consider a body of mass m suspended with a string of length L. When the bob is at rest, the net force upon the bob is 0 as the weight of the bob is equal to the tension in the string. As we have seen in class 9th, that weight of a body always acts directly downward towards the center of the earth, and when we suspend any body with a string, then a tension produces in the string, and direction of the tension would be just opposite to that of weight of the body, and its magnitude would be the same. So weight and tension both would be equal in magnitude and opposite in direction, therefore they will cancel each other's effect, and in this way the net force upon the pendulum bob or any body which is suspended with a string would be 0 at resting position or mean position. So weight is directing vertically downward, and tension in the string acts vertically upward. Both will cancel each other's effect and the net force upon the body would be 0. Let's see the simple pendulum. Let's move the bob to extreme position A. The net force is not 0 as shown in figure. First of all, we will see the weight. As we have seen that the weight of the body at resting position is directing downwards, but as we move it from the mean position to extreme position A, we see that the weight will be directing downwards, but if we resolve it into its components, we will see two components. As we have studied in class 9th, a force can be resolved into its two components, horizontal and vertical. Here we will resolve weight of the body acting at point A into its components, x and y component, and the net force along the string is 0 as the tension in the string cancels the component of weight mg cos theta. Hence, there is no motion along the string. As you can see in the diagram, mg cos theta is just opposite in direction to the tension in the string. And what is mg cos theta? It is x component of weight. and it is directing along the string. That's why both will be same in magnitude, opposite in direction, and they will cancel each other's effect, and net force on along this component, x component, would be 0. So the body will not move along the string. Then the next second component is y component, which is mg sine theta. This component of weight along mg sine theta is directed towards the mean position and acts as restoring force. So y component of weight, which is mg sine theta, is actually the net force which is acting upon the pendulum, and it is pulling the pendulum back from extreme position A to mean position O. Let's see or let's analyze the situation now. First of all, we will see the acceleration which is produced in the body. First point is, as the restoring force mg sine theta is directed towards mean position, therefore the acceleration will also be directed towards mean position O. As we have seen in class 9th, according to the second law of motion, when a net force acts upon a body, it accelerates the body in its direction. So here we have seen the restoring force would develop in the body due to its y component, which is mg sine theta. So and it is directed towards mean position, therefore the acceleration produced due to this restoring force would also be directed towards mean position O. Second point, the magnitude of acceleration will be maximum at extreme position A and minimum at mean position O. Why? Because as the body moves away from the mean position, its displacement increases, and displacement would be maximum at extreme position A. Therefore, acceleration produced in the body would be maximum. Why? Because the restoring force would increase as we move the body from mean position to the extreme position. So its value would be maximum. Restoring force would be maximum at A. Therefore, acceleration would also be maximum. And in other way, if we see or analyze the situation, displacement is also maximum at extreme position A. So due to these two things, maximum restoring force and maximum displacement covered by the body, acceleration would have the maximum value at position A. Third point, as the bob reaches at O, it will not stop here due to inertia and will start moving towards extreme position B. Restoring force develops again in the bob and the magnitude of acceleration increases and becomes maximum again at B. So when the body starts moving from position A to O, its acceleration would decrease due to decrease in restoring force, and it would become 0 at position O. But what happens at position O? The body would not stop. Why? Because of inertia. And inertia is the property of any body due to its mass, due to which it maintains its state of rest or motion. So it would not stop at mean position and it will go to the next extreme position, which is B. And while moving towards position B, restoring force would develop again. It increases and it would become maximum at position B. So acceleration would also be maximum at position B, and after stopping there, the bob would stop at B and then it is pulled back to the mean position O, and the magnitude of acceleration decreases and becomes 0 at O, which is the mean position. This way, the bob continues vibrating about mean position O. Let's see the velocity now. Due to restoring force mg sine theta, which is the y component of it. The bob will move from A towards mean position O. Velocity of the bob increases and becomes maximum at mean position. The bob will not stop at mean position O due to inertia, rather it starts moving towards extreme position B. As it moves, its velocity decreases due to restoring force and becomes zero at extreme position B. As it moves to mean position, its velocity increases again and becomes maximum. In this way, the bob moves to and fro about its mean position O. So, we can say that motion of simple pendulum is simple harmonic. Let's see the questions which you will do. First is define simple harmonic motion. Write characteristics of simple harmonic motion. Second, what is a simple pendulum? Third, prove that motion of simple pendulum is simple harmonic. So you will do all these questions and send me your work, and I will return it after checking. Thank you very much, and Allah Hafiz.